Welcome to this physics video where we'll explore a fascinating concept called the Master Unified Force Equation, or MUFE for short. This equation proposes that both Coulomb's law for electrical forces and Newton's law of gravitation might be manifestations of the same underlying principle, just at different frequency scales. Let's take a look at our master equation, which is F equals lambda times Q1 times Q2 divided by omega squared times r squared. Let's understand what each variable in this equation represents. F is the force measured in newtons. R is the distance between the charges measured in meters. Omega is a frequency measured in per seconds or hertz. Q1 and Q2 represent the respective charges of the two objects, which could be electric charges measured in coulombs or masses measured in kilograms when calculating gravitational force. And lambda is a universal constant that works for both electrical and gravitational forces, and its units will be determined through our dimensional analysis. Now, let's perform a dimensional analysis to ensure our equation is dimensionally consistent. We know that force is measured in newtons, which can be expressed as kilogram meter per second squared. Distance is in meters. Frequency is in per seconds. And the charges can be in coulombs for electrical force or kilograms for gravitational force. Let's analyze the units on the right-hand side. We have lambda times Q1 times Q2 divided by omega squared times r squared. Using the unit symbols, this gives us lambda times charge units squared multiplied by seconds squared divided by meters squared. We need this to equal the units of force, kilogram meter per second squared. So let's set up our equation. Lambda times charge squared times seconds squared per meters squared equals kilogram meter per second squared. Now, let's solve for lambda's units. Rearranging the equation, we get lambda equals kilogram meter per second squared divided by charge squared multiplied by meters squared per seconds squared. Simplifying this expression, we get lambda has units of kilogram times meters cubed per charge squared times seconds to the fourth power. This is the unique set of units that lambda must have to make our master force equation dimensionally consistent, regardless of whether we're dealing with electrical or gravitational forces. Now, let's see how our master equation reproduces Coulomb's law for electrical forces. In this case, we set Q1 and Q2 to be electric charges measured in coulombs, and we choose a specific frequency omega sub e for electrical interactions. We want our master equation to give us Coulomb's law, which states that the force is equal to k sub e times charge 1 times charge 2 divided by r squared, where k sub e is Coulomb's constant, approximately 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. Comparing our master equation with Coulomb's law, we can see that lambda divided by omega sub e squared must equal k sub e. This means lambda equals k sub e times omega sub e squared. Let's check the units. K sub e has units of Newton meter squared per Coulomb squared, and omega sub e squared has units of per second squared. Multiplying these, we get kilogram meter cubed per Coulomb squared per second to the fourth power, which matches exactly what we derive for lambda's units. Next, let's see how our master equation can reproduce Newton's law of gravitation as well. In this case, we set Q1 and Q2 to be masses measured in kilograms, and we choose a different frequency omega sub g for gravitational interactions. We want our master equation to give us Newton's law of gravity, which states that the force is equal to g times mass 1 times mass 2 divided by r squared, where g is Newton's gravitational constant, approximately 6.67 times 10 to the negative 11th meters cubed per kilogram per second squared. Comparing our master equation with Newton's law, we can see that lambda divided by omega sub g squared must equal g. This means lambda equals g times omega sub g squared. Let's check the units. G has units of meter cubed per kilogram per second squared, and omega sub g squared has units of per second squared. Multiplying these, we get meter cubed per kilogram per second to the fourth power times kilogram squared, which simplifies to kilogram meter cubed per second to the fourth power per kilogram squared. This again matches our derived units for lambda. Now, for a crucial consistency check. Since lambda must be the same universal constant in both cases, we can set up an equation. Lambda equals k sub e times omega sub e squared from the electrical case, and lambda equals g times omega sub g squared from the gravitational case. Therefore, k sub e times omega sub e squared must equal g times omega sub g squared. Rearranging, we get the ratio of frequencies. omega sub g squared divided by omega sub e squared equals k sub e divided by g. This fixes the relationship between the two characteristic frequencies. The gravitational frequency is much higher than the electrical frequency, since k sub e divided by g is approximately 10 to the 20th power. Let's visualize this on a frequency spectrum. Another interesting aspect of this unified force equation is the frequency threshold concept. We can introduce an on-off function f of omega divided by omega threshold, which equals the Heaviside step function of omega minus omega gap. This function essentially gates the force to zero below a threshold frequency. This suggests an interesting interpretation. The force only activates when the frequency exceeds a certain threshold. In plain language, if the oscillation isn't fast enough, no force is transmitted. This is similar to how some quantum forces, like the strong nuclear force, disappear below a certain energy threshold. Let's visualize this switch effect with a diagram. To wrap up our dimensional analysis of the master unified force equation, we've shown that F equals lambda times Q1 times Q2 divided by omega squared times R squared is dimensionally self-consistent. Lambda must have units of kilogram meter cubed per charge squared per second to the fourth power to make the equation work. By choosing the appropriate characteristic frequency omega, we can reproduce Coulomb's law for electrical forces with omega equals omega sub e, Newton's gravitational law with omega equals omega sub g. The key insight is that both forces might follow the same underlying principle, just activated at different frequency thresholds. This unified perspective suggests that seemingly distinct forces in nature might be manifestations of the same fundamental interaction, just tuned to different frequencies.